I wish to present a lecture I gave in America this year of 2014 on relativity. I didn't make a very good recording of it myself, so I'm presenting it again afresh from my lecture notes. The title is Revisions to Relativity and its History. There have been numerous revisions to relativity. I will only give a rough outline. For those criticising relativity, there has been a problem that mainstream has not often made it clear about these revisions. The lecture is going to be split into 3 parts. The first part is the history of relativity after Einstein. Second part is the history of relativity before Einstein. Third part is a little bit of maths. Part 1. Einstein is usually portrayed as discovering relativity theory. Although Poincaré, Lorentz and others were involved, there is a tendency to ignore this. Also, there is a renaissance of relativity, which is basically a rewrite of Einstein's relativity. Now, this is a famous physicist. He's Oppenheimer, and he's considered to be the father of the atom bomb. Oppenheimer considered Einstein as an idiot. Quote, referring to Einstein, early papers are paralysingly beautiful, but they are thoroughly corruptive errors. Others have considered Einstein an idiot, but often their reputation was damaged by doing that. And I wanted to point out that this is completely opposite to what they say to the public about Einstein. Now, Wheeler resurrected Einstein's relativity theory. Charles Milner, quote, says, "What I think is the most important contribution John Wheeler made to pull general relativity out of the discard pile and get large numbers of good people actually working on it." And that's quoted in that book. So, when he was discarded, Einstein's relativity was basically taken to the landfill, but then Wheeler brought it back. What then followed was a renaissance of relativity, and the problems of relativity were supposedly sorted out. But looking at it, there are still major problems, and we have a confusion of what Einstein said, and these later relativists are supposedly changing that. So this is Hans O'Hanlon. He's a professor of relativity, and I think he comes out of the Wheeler School of Relativity, and he's written this book called Einstein's Mistakes, and in the book he points out some of the mistakes that Einstein is supposed to have made. It makes everything confusing that there's a Wheeler School of Relativity, and they're not clear what they have changed and why. Now, this is Sheldrake. He's a maverick biologist who's got some very controversial views about biology. But he has had a banned lecture. And if you go to that link, that's where the banned lecture is. He says a lot of interesting things, but there's one thing I want to pick up on about experimental physicists have admitted to him they weren't able to measure the speed of light as constant, and so have defined it as constant. I got the clip, so hopefully I'll get to that clip now and show you that bit. Escape. Right. Here we go. This is the banned lecture by Sheldrake. He first of all talks about his hypothesis of morphic resonance, and then he wants to go on to consider some things about physics.
Of morphic resonance. Everything depends on evolving habits, not on fixed laws. But I want to spend a few moments on the constants of nature too, because these are again assumed to be constant. Things like the gravitational constant, the speed of light, are called the fundamental constants. Are they really constant? Well, when I got interested in this question, I tried to find out. They're given in physics handbooks. Handbooks of physics list the existing fundamental constants, tell you their value. But I wanted to see if they'd changed, so I got the old volumes of physical handbooks. I went to the Patent Office Library here in London, and they're the only place I could find that kept the old volumes. Normally people throw them away when the new values come out. They throw away the old ones. When I did this, I found that the speed of light dropped between 1928 and 1945 by about 20 kilometers per second. It's a huge drop because they're given with errors of only fractions of decimal points of error. And yet, all over the world, it dropped, and they were all getting values very similar to each other with tiny errors. And then in 1945, it went up at 48, it went up again. And then people started getting very similar values again. I was very intrigued by this, and I couldn't make sense of it. So I went to see the head of metrology at the National Physical Laboratory in Teddington. Metrology is the science in which people measure constants. And I asked him about this. I said, what do you make of this drop in the speed of light between 1928 and 1945? And he said, oh dear, he said, you've uncovered the most embarrassing episode in the history of our science. So I said, well, could the speed of light have actually dropped? And that would have amazing implications if so. He said, no, of course it couldn't have actually dropped. It's a constant. So, well then how do you explain the fact everyone was finding it going much slower during that period? Is it because they were fudging their results to get what they thought other people should be getting, and the whole thing was just produced in the minds of physicists? We don't like to use the word fudge. I said, well, what do you prefer? He said, well, we prefer to call it intellectual phase locking. So I said, well, if it was going on then, how can we be so sure it's not going on today? And that the present values are produced by intellectual phase locking. And he said, oh, we know that's not the case. I said, how do we know? He said, well, we've solved the problem. And I said, well, how? He said, well, we fixed the speed of light by definition in 1972. So I said, but it might still change. He said, yes, but we'd never know it because we've defined the meter in terms of the speed of light. So the units had changed with it. So he looked very pleased about that. They'd fixed that problem. But I said, well, then what about big G?
Okay. So the bit I want to emphasise is about the speed of light. He goes on to make interesting points about the gravitational constant as well, and that is also related, but I'm concentrating on the speed of light. And the situation with the speed of light is they were never able to actually measure it as constant in the context of special relativity, where they try and consider constant velocity motion. They were never actually able to measure it as constant. And so what they did was they defined the speed of light as constant. And that is two different theories. If you assume that the speed of light is constant, what you then do is go out and do an experiment to find out whether the speed of light is constant. And you can answer that yes or no. It's a different theory to define the speed of light as constant. A completely different theory to do that. If you're defining the speed of light constant, you are not then doing an experiment to find out whether the speed of light is constant. You're just fixing it that way. And as pointed out in that talk, if you're doing that, you are then messing around with the units of measurement. You're not only messing around with the meter's being defined by the speed of light, but also time itself is. So the consequence of defining the speed of light as constant is to measure your measurements units. Right. Next I will show you a person I've been in contact with if I can find it here. It was an article here in the Engineer. Was Einstein wrong? Associate Professor Reg Cahill from Australia is trying to demonstrate that Einstein was wrong. He is well aware that his activities will not make him popular with the establishment in physics. He believes other experiments have produced data that conflicts with Einstein's theories have been deliberately ignored or in some cases suppressed. Einstein's invention of space-time merged the geometrical models of space and time and was predated on famous 19th century experiments by Michelson Morley that purported to show that the speed of light was constant in a direction. So what we got is those experiments did not actually show the speed of light was constant as revealed in the Sheldrake lecture. The physicist was admitting to Sheldrake they did not find the speed of light constant. They were not able to do that. But of course, that has not been what been taught to the physics students. They have been taught the lie that the Michelson-Morley experiment showed the speed of light constant. That is a lie. They were not able to do that. When the very small effect was recorded as opposed to the large one anticipated, the two physicists, that would be Michelson-Morley, decided the effect could be discounted as an artifact of the experiment. They declared the result to be null, and the constant speed of light became part of the theoretical basis for Einstein's theories of special relativity and general relativity. Professor Cahill says they were wrong. They threw the baby out with the bathwater. The effect was real. The speed of light is different in different directions. So I was attended a talk by Reg Cahill, and he's gone into more details about it with me and others there during that talk. Basically, when you look at the data, the speed of light is not constant from experiment. So what we have is a situation of students being falsely taught that the speed of light is constant, and hence there is experimental evidence for Einstein's theories of relativity, which mostly special relativity. There wasn't. They were falsely told that there was evidence when it turns out there wasn't evidence. Therefore, they then panicked. They had what would come termed to in the Sheldrake lecture as an embarrassing incident. They had to find out what to do next, and so rather than face the consequences of Einstein being wrong, they decided to define the speed of light as constant. And that's just a bodged job, because that theory is not what was originally intended. The theory they have now is a revision. They were teaching the theory where the speed of light was constant as observed from experiment to students, and now they're pretending it's a different theory. They're pretending it's a theory where the speed of light is defined as constant, and they're ignoring experiments. They're ignoring experimental evidence. By having the speed of light defined as constant, it is now no longer testable. And if it's not testable, it is not really a proper scientific theory. Scientific theory has to be testable. If we go back here, I had an email from Professor Cahill, and this is where he talks about it. Hi all, in my NP, Natural Philosophy, Baltimore presentation, PD, as well as some publications dealing with dynamical space and its detection over more than 100 years. That's basically his theory of dynamical space. And now, using the very simple and cheap quantum detector technique, as expected, the physics ARXIV have banned my submissions reporting the design and operation of the quantum detector. Obviously, we can't have people doing experiments that contradict special relativity. And by special relativity, he means the original version of special relativity, where it is supposed to be a scientific theory, rather than the later theory where it is defined as constant. And it's Professor Cahill, School of Chemical and Physical Sciences, Faculty of Science and Engineering, so forth. And this is what we find with academia. There is too much of a fan club for Einstein, and they don't really want to accept what they've done. They have taken on a theory which does not really work, and when they, in their desperation, they have now committed this farce of defining the speed of light as constant. Okay. I can go now back to my lecture. Here we go, move it on. Sheldrake. So, Sheldrake band lecture, the interesting point I want to point out, experimental physicists admitted to him they were unable to measure the speed of light as constant, and so they've defined it as constant. Now that sort of thing they try to keep out of the physics textbooks, and they're so embarrassed by it they don't really mention it much in their physics papers when they publish them. When it comes to reading science papers, it's usually, I think, more interesting to see what they have deliberately missed out. That is very illuminating as to what they're trying to cover up. And when it comes to experiments, they are trying to miss out that they've really messed them up bad. The speed of light constancy postulate. It's not really clear what Einstein meant by the speed of light constancy when he introduced it in 1905. Roughly, it can be taken to probably mean that all inertial observers measure the same value of the speed of light in vacuum free of the influence of fields. However, moving on since him, the speed of light has been defined as constant in a different theory, and that's a different theory to the one where you define it as constant independent of it being defined as constant. So what theory did Einstein really mean? It seems to me that this renaissance of relativity, which happened with John Wheeler, has changed the theory as to what light speed constantly means. They now have it to mean defined as constant. And this issue I'm going to pick up in Right, part 2. Relativity before Einstein. Of course, relativity was around before Einstein, and we can go back to Galileo. One of the great findings of scientists is that the laws of motion are the same in frames of reference that move with constant velocity with respect to each other. This is called the principle of relativity. And I'm quoting from that site. This comes from Galileo. What Galileo did was have one of his cronies standing on the top of the mast of a fast-moving ship and drop a ball. I presume this is probably, I'm not really sure whether this experiment actually happened, but it illustrates what happens. If you've got a ball here and you let go of the ball, the ship moves forward and the ball hits the deck. So an observer on the shore sees the ball move in that path, but a person on the deck sees the ball move straight down, only sees straight down motion. By the time the ball landed, the ship had moved some distance. Did the ball drop behind the mast? Nope. It dropped right under the release point, just as it would have had the ship not been moving. That is from the point of view of Galileo's friend. The ball just dropped down, just as if the ball was stationary. And I'm pointing out that I'm quoting this website who's saying this. Galileo stood on the bank watching. From his point of view, the ball moved in a parabolic arc, landing further down, as shown by the dotted line in figure 1, which is that dotted line. I think you get the general idea, so we'll move on. A lot happened in relativity between Galileo and Einstein. Most of it gets missed out. In the 18th century, a lot of physics was written in Latin, and I'm now translating it. It has been mostly ignored, and as a priest, Father Boskowitz was dealing with relativity. This is a picture of Boskowitz. He was also talking about quantum physics, because quantum is a Latin word. I.e. he was talking about physics and using the Latin word quantum. He had a theory unifying quantum and relativity, what we nowadays call a unified field theory, but I emphasise this was an 18th century unified field theory. Right. So what I'm talking about is Galileo, as Boskowitz had a unified field theory in the 18th century. And things were a bit different there from what Einstein was talking about. Now if you go back to this guy again, Wheeler from the School of Relativity. According to that school, Boskowitz's theory is a unified field theory. However, they're ignoring it because it is an 18th century unified field theory and they're looking for a more modern unified field theory. Reason they look for a new unified field theory is because of Einstein's relativity prompting them to do that. But they have revised Einstein's relativity, and Einstein made lots of mistakes. So undo all the mistakes, and I say we are back to the 18th century unified field theory. Basically what I'm saying is Einstein introduced a lot of mistakes into physics, and you undo all those mistakes and you're back to a unified field theory. And it's the 18th century unified field theory by this person, Boskowitz. All Einstein's done has managed to put the physics community onto massive diversion from what they're looking for, namely a unified field theory. So part 3 is the maths. There are too many problems with Einstein's relativity, so I only deal with one issue of that mess, namely the derivation of time dilation. I will present the usual derivation of time dilation, then re-look at it. Right, this is time dilation, and I'm quoting a site. This is standard time dilation derivation, where you have light bouncing up and down between two mirrors going a distance L. And when these mirrors move with the light bouncing up and down, then the light from that mirror goes in that direction, hits that mirror at the top, then bounces back down again. And by that time the mirror's moved. This mirror moved here. So what we're forming from this is a Pythagorean triangle. If the velocity is v in that direction, then the distance travelled is vt. in time t, and we're taking the distance along here as being L. And this is an explanation of it as given at that website. A clock is made by sending a pulse of light towards a mirror at a distance L and back to a receiver. I think you get the general idea. So some notation. T is the time for light to reach the mirror in the lab for a clock at rest in rocket 1. T dash is the time for light to reach the mirror in rocket 1's rest frame. L equals the distance to the mirror, that's the vertical distance. So the times and distances are related as follows. L equals c t prime, and then by Pythagorean theorem we can form this. And Pythagorean theorem is the square of the hypotenuse is equal to the sum of the squares on the other two sides. So if we go back, that's L squared plus V squared T squared, and that equals that distance squared. Simple Pythagorean theorem. So eliminate L from the equations, just a bit of manipulation, and then we get T prime equal to T times this expression, and that is called the time dilation equation. That's how they derive time dilation. But now I want to look at the Pythagorean triangle again, which they're using. This hypotenuse is CT, the horizontal is VT, and the vertical is that. So the question becomes, why do they equate this to CT prime? If we were doing Newtonian physics, then we wouldn't have T different to T prime. We would instead have T as equal to T prime. And if we did that, we would have C prime is equal to the square root of C squared minus V squared. That equation. In other words, C along there, V along there, along here, C prime. Nothing about, in other words, the speed of light along there is not the same value as the speed of light along here. In general, we have the equation C prime T prime is equal to the square root of C squared minus V squared, all times T. Einstein's take C prime equal to C. We take that as equal to that C there. And when they do that, they get T different to T prime. But we shouldn't really do it that way. We should really be doing it by Newtonian physics. And by Newtonian physics, that T should be the same as T prime there. And when we do that, C prime is equal to the square root of C squared minus V squared. In other words, the speed of light is not constant. The speed of light is changed. You've got the speed of light C there, and another speed of light value here, C prime. It's not constant. Of course, the way that the Einstein followers talk with their T and T prime being different, they go on to say things about the effect on space and time. So them having C equal to C prime then gives them the space-time effects. It was referred to in the band lecture by Sheldrake, where they've defined the speed of light as constant, which seems to be that, and they will never now know whether the speed of light is not constant, because their unit of the meter changes, and also, which wasn't mentioned, their unit of time would change as well. So by doing that, they have corrupted their units of distance and time measurements. So they have, in their revised theory, C equals C prime as a definition. But why are they doing that? Because in Newtonian physics they should not be doing that. So let's look at the logic. There is a thing called proof by contradiction, and the method of that is to make an assumption, look at the consequences of that assumption. If that leads to a contradiction, then it disproves the assumption. So let's apply this to Newton. Apply this to Einstein. He starts by assuming light speed constant. Relativity principle is part of Newtonian physics. That is what Galileo gave us, the relativity principle. So in his 1905 paper on relativity, this is Einstein's, when he starts from two assumptions, the relativity principle is part of Newtonian physics. The only thing that is seemingly new is the light speed constant assumption. He's not clear what he means by it, but in the maths he has C equals C prime, and that gives him time dilation. Now apply proof of contradiction to this. He is adding the assumption of light speed constancy to Newtonian physics. He gets time dilation from this. In Newtonian physics there is no time dilation. Therefore, by proof by contradiction, the assumption of light speed constancy is false, but he does not follow logic. I will go back on this a bit. By the proof by contradiction, when he discovers there is time dilation from assuming light speed is constant, that should show that the assumption is false. That's if he's working from Newtonian physics. Working from Newtonian physics, add the assumption of light speed being constant, it leads to a contradiction. It's therefore false. However, he does not follow logic. Instead, Einstein does the following. He assumes light speed constant. He then adds to that, he assumes time dilation. He then keeps adding more assumption. He assumes length contraction. He assumes change to momentum, which he calls relativistic momentum. He just keeps adding more and more assumptions. He adds more and more assumptions, and the more assumptions that he adds, the more the change there is from Newtonian physics. There is no justification for this change. He violates logic. Right, so I go back again to this. Applying the proof by contradiction to what Einstein does, if he is working from Newtonian physics, then when he got time dilation, he should have decided that his assumption of light speed constant is false. But he didn't do that. He just decided to abandon logic. Right. Oh. I have another person on a similar track to this. It's a Glenn Baxter. He looks at this and he says C is equal to C prime is a mass mistake. I look at it and they seem to have defined C is equal to C prime as revealed by Sheldrake's band lecture. So when they do that, they are defining 1 equals 2 effectively. So I had difficulty with saying that C equals C prime is a math mistake. saying C equals C prime is equivalent to saying 1 equals 2. If you do maths where everyone agrees that 1 does not equal 2, and in pages of mathematical calculations you have hidden away there 1 equals 2, then we could all agree that it was a math mistake. But with Einstein, it now seems that 1 equals 2 is allowed. And he has maths based on that. So calling it a math mistake is more difficult to my mind. It's more like what he did was abandon reason. He came up with some maths and he abandoned reason to do that. He abandoned logic, he abandoned reason. So the way I look at it, from this basic equation, by Newtonian physics, we would look at that equation and say t prime equals t, that t prime would equal that t, and then that c prime would equal that. But Einstein and his followers, implicitly or explicitly, do not do it that way. So the question I would ask them is, why the change? They might say they are going by experiment, to which I would counter, I refer you to the banned lecture of Sheldrake, which points out they are going by definition, equivalent to saying 1 equals 2. The original theory might have been assume light speed as constant and then check it by experiment, and that is the way it has been presented to many physics students, but they're not doing it that way anymore. They are now defining light speed as constant, and so they are defining 1 equals 2. Conclusions. So we have been profoundly messed up by Einstein. There are many mistakes in Einstein's work. See example Harry Ricker's work, Nick Percival, Stephen Crothers, Hartwig Thim, etc. These and many other dissidents I'm in communication with, all saying that Einstein's wrong, but they're all picking up on different things. So, Einstein being portrayed as a hero has made it difficult to correct these mistakes, because those who do try to correct those mistakes risk getting speared by the hero worshippers. Einstein is a hero, and the people who worship him as a hero don't like Einstein being pointed out as being wrong. The establishment has been persecuting many dissidents, making them modern day Galileos. And my example is this person, Eason. The establishment has become more skilled in persecuting Galileo type people. In Galileo's time, the establishment responded by threatening him. That failed as an adequate method to suppress dissent. So they have become more skilled since then at suppressing dissent. They do it namely by rewarding you with prizes, e.g. the Nobel Prize, and funding you for research if you don't dissent. So what they've used basically is a carrot and stick approach, where they found that making the carrot bigger was better at controlling dissent than use the stick. They used the stick on Galileo, it didn't work, so now they use the carrot. And that's the end. Basically, I need to clarify that the way they use the carrot is, if you agree with us that Einstein is a genius, here's your carrot. If you want to say Einstein is not a genius, then we try to take your carrot away from you. That's how the carrot is used. End of lecture. Thank you.